Hi everyone, it's Miss Logan. Today we'll be talking about our kinematics equation in the horizontal direction. So as a reminder, here are our velocity and accelerations equations. Remember, this D and this triangle means the change of something. You will see that very frequently in science and math classes. So for velocity, we have our change in displacement over change of time. We can also look at that our final distance minus our initial distance over our time. Our acceleration equation is very similar. We have our final velocity minus our initial velocity over our time. Our kinematics equations are related to our velocity acceleration equations, however we combine them in different ways. So here's the most important slide. These are our kinematic equations, okay? These are the three equations we will be using in our horizontal direction and our vertical direction. Today we'll be only talking about our horizontal direction. So let's talk about them. Our distance equals 1/2 of our acceleration times time squared plus our initial velocity times time. So velocity initial can be written in several ways. It can be written how we see it here, V0. I normally write it V1 or V initial. Our second equation, our final velocity is equal to our acceleration times time plus our velocity initial. This is our acceleration equation just rewritten. Our last equation, we have our final velocity squared equals 2 times a times d plus our initial velocity squared. Before we begin using these equations, I just want to clear up a big misunderstanding in physics. We will often see this word called decelerate. Mostly it means to slow down. This is probably a really terrible word to use in physics. What we need to use is accelerate in the negative direction. Often when I say decelerate, we may not think of the negative direction. If I say accelerate in the negative direction, you will know that there needs to be a negative sign here. So make sure when you see decelerate, you are thinking of acceleration in the negative direction. So our first sample problem. A car accelerates from rest to 5 meters per second squared. What is the velocity of this car after 18 seconds? The first thing we always do when we get to problems is write down what we know. So first we know the car accelerates from rest. So our initial velocity is 0. It is not given in this problem, but it's something we can assume. We also know our acceleration is 5 meters per second squared. And we know our time is 18 seconds. What am I looking for in this problem? I am looking for the final velocity. This box right here needs to be on every single one of your problems. These are our givens and our unknowns. So if we look back at our kinematics equations, we should see that we are going to use our VF equals A times T plus V0. Why? I'm looking for V0 or VF, and I have V0, A, and T. So let's plug our numbers in. And our final answer is 90 meters per second. Our second sample problem. A motorcyclist is moving with a velocity of 45 meters per second. He accelerates at 3.5 meters per second square. How fast is he traveling after 6 seconds? Let's write down our knowns. So we know our initial velocity is 45 meters per second. We know our acceleration is 3.5 meters per second squared. And we know our time is 6 seconds. What are we looking for? We're looking for our final velocity. Looking back at our equations, we are looking for final velocity. We have our initial velocity, acceleration, and time. So we're going to use VF equals AT plus v0. Let's plug in our numbers. And our final answer will be 66 meters per second. Okay, so our final problem. So my tires provide a maximum acceleration of negative 7.8 meters per second squared, which we may also call deceleration, but not in my class. And that's on a dry road. If the skid mark that was left is 92 meters long, was the car speeding if the speed limit was 50 miles per hour, which is also 22.2 meters per second on Auburn Road? Okay, so what we know from this problem. We know that my acceleration equals negative 7.86 meters per second squared. I know the distance I slowed down is 92 meters. And I know my final velocity, because it's a stoplight, is 0. What am I looking for? I'm looking for my initial velocity. Okay, I'm trying to figure out how fast was I going, was I speeding? So I know my acceleration, my distance, and my final velocity. I'm looking for my initial velocity. So we'll use our equation VF squared equals 2AD plus V0 squared. So how do I determine which equation I'm using? I need to see what I already know. This will take time and practice in doing equations. Let's plug all our numbers in. So I have 0 equals 2 times negative 7.86 times 92 plus my V0 squared. This is what I'm looking for. Okay? So if I work out my math, I have 0 equals 144624 plus V0 squared. Move everything over. Square root both sides. And I get 38 meters per second. Alright, so right now these are your follow-up questions. Make sure you're following the same exact process that I did. The most important part is that you submit a picture of your answers and work on Google Classroom. Thank you for listening. Bring all your questions to class.